Okay, guys, just so you know, I think 7 students emailed me a video of their head actually exploding when they watched that video, Which Way the Equation Goes. So I'm going to try to simplify it even further, if that's possible, without losing meaning. Because again, look, I'm starting out with pH and how it's controlled because it's really important, right? If it wasn't, I wouldn't spend any time on it, right? I'm not going to spend any time on the patella, even though that's important. It's not as important as pH, all right? So look, you watch the video on chemical buffers. If you haven't watched that video, Which Way the Equation Goes in the chemical buffers, you better. That's all I can tell you. So look, in that video I told you that any substance that gets dissolved in bodily fluids and produces free-floating hydrogen ions is an acid. So when CO2 gets dissolved in bodily fluids, which are mostly water, right, it forms this stuff, carbonic acid. And then carbonic acid is going to dissociate, break apart into free-floating hydrogen ions and bicarbonate ions. So anything that gets dissolved in bodily fluids and produces free-floating hydrogen ions is an acid. So that's how CO2 is an acid. Now, I'm going to take a little, professional liberty here, I guess. And what I'm going to tell you is carbonic acid, this guy, is kind of like a referee, right? Kind of like a parent. So if you think of one kid as CO2 and the other kid is bicarbonate, whatever you do to one kid, you got to do to the other, right? So the things are equal. So in chemistry, you want an equation to be in equilibrium, meaning both sides are equal. In the body, you want it to be in homeostasis. So with respect to pH, you got to maintain that pH because the critical proteins of the cells of the body maintain their ideal shape at 7.35 to 7.45. So enzymes control all the chemical reactions inside your cells. If you jack up the pH, you're going to jack up the enzymes, and then you don't work so good. So that's why it's important. So what I did is I came up with this little teeter-totter thing, right? This little balance. Now, you should be getting a handle on at least chemical buffers, and then the difference between chemical buffers and physiologic buffers. And as I stated in the video, physiologic buffers are systems that help maintain the pH of the blood. And we know that the respiratory system and the kidneys are intimately involved in maintaining the pH. The kidneys, as I stated in the video, can correct any pH imbalance if you live long enough, right? So if you maintain blood flow to your kidneys and your kidneys are operating, if your heart's working and pumping that blood to the kidneys can correct any pH imbalance. The respiratory system, on the other hand, you're not going to have somebody come into your emergency room going, I've been breathing like this for 17 years. I thought I should do something about it, right? So the respiratory system's not going to compensate indefinitely. It can compensate quicker than the kidneys, but not indefinitely. The kidneys, they're the players, right? That they're going to make a difference. Now, I just explained to you that CO2 is an acid, right? Because it forms free-floating hydrogen ions. So if you look, you have to balance this CO2, which is an acid, with bicarbonate, which is a base. right? So there has to be this balance between acid and base in order to maintain that pH. So if we look, right, we know that the respiratory system controls carbon dioxide. And as I explained to you in the video, let's say, for example, that your lungs aren't working so good. That, who cares why, right? Your lungs aren't working so good. So if the lungs can't get rid of enough CO2 like they're supposed to, then CO2 is going to go up. And if CO2 goes up, right, if you balance, right, if you got to make this thing balanced, if CO2 goes up, and that's the same thing as saying free-floating hydrogen ions, right, and we know that the respiratory system controls carbon dioxide. So if the amount of CO2 goes up, to keep it balanced, you have to do what? What do the kidneys have to do to the amount of bicarbonate in the blood? Well, what do they have to do? I'm waiting. I'm not hearing an answer. That's because nobody's here. So if CO2 goes up, the lungs are having a problem. Then the system that's going to compensate is the kidneys. And because the kidneys control bicarbonate, and bicarbonate is a base, if you add more acid to the blood, then the kidneys have to add more base to the blood. And that's exactly what they do. So in a respiratory problem, the only system that can compensate for it, help out, if your lungs ain't working, are your kidneys. And they will compensate by increasing the amount of bicarbonate circulating in the blood. And that's a huge concept. Because once you get into clinicals, they're going to be asking you how to interpret arterial blood gases. And people don't get that. Well, you're going to get that. So hopefully you understand that. And where do you make CO2? Well, you make CO2 as a normal byproduct of metabolism in the cell, right? So I explained it in the video, right? CO2 is going to move from the cell into the blood, and then all that venous blood comes back to the right side of the heart and then goes to the lungs. And that blood gets into the pulmonary capillaries and the alveoli, and you get rid of that CO2. But if your lungs aren't working good and you're holding on to that CO2, you got to maintain the pH. So if the amount of acid goes up, then the amount of base has to go up in order to maintain that pH. And the kidneys control bicarbonate, which is the primary base of the body. Boy. Right? So, and we also know that bicarbonate is a buffer, and you better know the definition of a buffer. And the definition of a buffer is not a chemical that helps maintain or prevents big swings in pH. I want you to understand that chemical buffers can grab onto hydrogen ions or let go of hydrogen ions depending on the pH, right? That's the true definition. And bicarbonate is a big one. The other one, of course, is albumin. And you need to know this stuff. And I'm telling you what you need to know, right? Okay, so now let's look at this. There we go. You got the capillary and you got the cell. And again, who cares why? Here's the cell. And let's say, for example, that the cells of your body, through metabolism, right? The cells are making energy, right? Through metabolism, the cells are making more hydrogen ions than normal and dumping them into the blood. You got me? What's floating in your blood that could grab them and then lock them up in carbonic acid? So if the cells are making more free-floating hydrogen ions than normal, there's a normal blood level for bicarbonate, right? So how does a doctor or nurse know that the cells of the body are making more hydrogen ions than normal? Well, let's look at our equation. What's the only thing that affects pH? The only thing that affects pH are free-floating hydrogen ions, right? That's what you need to understand. Who kind of helps balance the equation? Carbonic acid, right? Now look. You got a certain normal amount of free bicarbonate floating in the blood. So if the cells of the body, through metabolism, start producing more hydrogen ions than normal, if they remain free-floating, then the pH will begin to drop. But what can handle them? What can grab them and lock them up so they're not free-floating? Our buddy, our pal, bicarbonate. So bicarbonate will grab them as those hydrogen ions are dumped into the blood and then lock them up in carbonic acid. Now, here's the big question. If this situation exists, the one I just explained to you, through metabolism, they're dumping more hydrogen ions into the blood than normal, what should happen to the circulating level of free bicarbonate? What should happen to the amount of bicarbonate that is free in the blood? I'm waiting. Nobody's here. What's going to happen is the bicarbonate is going to drop. Why? Because it's grabbing the extra hydrogen ions and then locking them up in carbonic acid. So you're essentially using up your bicarbonate. That's critical. Now let's look. Watch. In this case, what's going to happen? Watch. If the bicarbonate level goes down because the cells of the body through metabolism are making more hydrogen ions than normal, then to keep the little teeter-totter balanced, what has to happen to the amount of carbon dioxide? Hopefully you said please, right? Watch. If you're dropping the base, because the amount of free bicarbonate, base bicarbonate in the blood, to maintain the pH, you then have to drop the amount of acid in the blood, because the acid and base have to be equal. And I told you CO2 is an acid. So in cases of what's referred to as a metabolic acidosis, where through metabolism the cells are dumping more hydrogen ions into the blood, the respiratory system compensates by blowing off more CO2 than normal. And there's a condition that we'll learn about. It's called Diabetic Acidosis. And when people go into a diabetic ketoacidosis, the cells of the body are dumping a bunch of extra hydrogen ions into the blood. Bicarbonate is going to grab them and lock them up and you're going to use up your bicarbonate. But now on this equation, you've lowered the bicarbonate, so you have to lower the CO2. And as a result, these people will breathe faster and deeper. They'll have what's referred to as Kussmaul respirations. And more about that. My point is that temporarily, in a metabolic acidosis, the respiratory system will compensate by breathing out more CO2 than normal. If you have a drop in bicarbonate, because bicarbonate's grabbing it and locking up those extra hydrogen ions, then you have to decrease the amount of CO2 in the blood in order for that equation to be balanced. Now again, people ain't going to do this forever, right, for 17 years. So you got to work on to correct that DKA, otherwise they're going to be running into problems. So hopefully that helped a little bit, right? But you got to be on this stuff. Again, this ain't a sometime thing. It's an all the time thing. And, well, that's all I got to say. You got me? All right.